Good evening, sir. Today we are excited to share our in-depth analysis on the mass shootings dataset for US. I, Abhinav Rawat, will be covering the key objective points, the key motivations, as well as a brief overview on the data itself. So this, through various statistical tests that we conducted on this data, we aim to uncover patterns that we can find within the data itself. And these patterns can help us provide an invaluable insight into the data and help us preventing mass shootings in the US in the near future. Our study utilizes the Violent Project Mass Shooter database. Using hypothesis testing methods and various time analyzing methods, we aim at uncovering the spatial and temporal patterns that can be found within the data itself. Now we come to the key motivations. Our key motivations involve identifying prevention patterns, guide evidence-based policies, inform public disclosure, advanced academic understandings, and predicting future trends. Essentially, we're converting raw data into actionable insights to help foster a safer society in the United States. The study provides emphasis on trends identification, the correlation between different features, and predictive modeling, for example, the ARIMA model. The Violent Project dataset acts as a comprehensive repository for valuable data. It contains incident specifics, perpetrator demographics, motivations, mental health histories, behavioral patterns, and much, much more. The way this dataset was constructed was using various public sources such as public records, personal accounts, secondary sources, etc. There were extensive checks made to guarantee that the data was precise. There were limitations posed by the privacy laws, the media biases, and incomplete reporting, which we had kept in mind while conducting our analysis. Here we can see visualizations of few of the features such as high school graduation rates, the college graduation rates, etc., state-wise. Here we can see the temporal trends for some of the features, such as the population, the total murders, the US murder rate per million, the mass shooting rates, average deaths per shooting, the mass shooting incidences, deaths in mass shooting, and much more. So now I'll hand it over to Julian to take it further. Thank you.
Okay, so my analysis focused on the predictive modeling of mass shooting incidents using machine learning techniques. The primary goal is to understand the relationship between socio-economic factors and the number of victims in mass shooting. I choose the random forest regressor model for its versatility and ability to handle complex relationships within the data. And here's my hypothesis. The null hypothesis posits no significant relationship between socio-economic factors and the number of victims, while the alternative hypothesis suggests a significant correlation. And here's the data and features. I use the community data to do my analysis. And the key features are the employed rate, high school graduate rate, and college graduate rate in the city that happened the incident. And the target variable is the numbers of victims in the mass shooting incidents. And here's my model development. The random forest splits the dataset into training and testing sets, which in my case I use 80% for training and 20% for testing. And it uses a method called bagging, where the random forest use Bootstrap to create estimators from the training dataset and then throw in the testing datasets and average all the results from the estimator, which becomes the predicted value. And then and the mean square error shows the residual between the true value and the predicted value. And here's the result. The resulting mean square error was 39.85, which is quite large, and the result is not significant. And below are figures of the regression plots, residual scatter plots, and residual histogram. We can see that a lot of data are crowded in the bottom left, which implies the reason for the poor performance is due to the distribution of the datasets, where most of the numbers of the victims in the data was between 3 and 5. And as you can see in the histogram, there's a lot of minus, which means residuals will become minus because the predicted value was bigger than the true value. And this is probably the reason why the testing isn't significant. And that's all for my part.
So our objective here was to analyze if there was a positive correlation between the graduation percentages in a state and the number of mass shootings happening in that state. So for the graduation percentages, that is what population of the state has graduated their at least bachelor's degree, we used data from a credible external website data source, and for the state-wise number of shootings, we use the usual mass shooting database. Uh, uh, we use the Pearson's test for this, and after running the test through our data, the results, that is the Pearson correlation coefficient and the p-values, indicated that there is no significant correlation between the graduation percentages and the mass shootings. That the so I think we could say no matter the literacy rate, the mass shootings were random. So here's a visualization of the graduation percentages and mass shootings. As you can see, it's very random and there isn't a correlation, and the regression line does not go through all the points. For our next hypothesis, we use the Spearman's test, and our goal here was to determine if there was a correlation between the legality of the firearms that were used, if they were purchased legally or illegally, and the number of mass shootings and the number of victims in a mass shooting. So we used the data from the mass shooting database, and after running the test, uh, we concluded two things. One thing was if most shootings had legal firearms involved, that is, there were more legal firearms in shootings, but in in shootings where there were illegal firearms, there were more victims. So I think this could imply that illegal firearm purchases also meant they had a bigger ammo cache, since there is no limit on how much ammo you can buy because they were buying it illegally. So yeah, and this is a visualization of the number of victims in illegal and legal purchases. For and Our next hypothesis was we wanted to determine if there were more killings or more mass shootings in weekends compared to weekdays, and for this we use the chi-square test. Uh, the results were very clear. It indicated that there is no, like, there is almost zero relationship. There is zero uh, yes, there's zero relationship if between the number of mass shootings and if the shooting happened on a weekday or a weekend. So this suggests that shootings are random, and shooters do not choose weekends as I expected because there would be more people out on the weekends. And this is a visualization of the weekday shootings and the weekend shootings.
So in this section, we did a deep dive into the analytical study of US murders and mass shootings over time. So we actually did a time series analysis, basically to uncover hidden patterns and predict future events, with the ultimate goal of just understanding these phenomena better. Our primary objective was to investigate if there is an underlying order to these events, and that if a model such as the ARIMA model could actually capture it, which would eventually allow us to make informed predictions. In this type of scenario, in this type of case, it's not really just about the numbers, it's about understanding the rhythms of these events over time. So for our hypotheses, what we chose were two very contrasting hypotheses, the null being that it assumed that the data was actually random, unpredictable, without pattern, while our alternative was completely the opposite. Alternative predicted that there was a hidden structure, a pattern that persists through time, something that we could actually model and predict from. So for our data set, we cleaned and prepped it for analysis. The data set includes the years, the total US murders, the total number of mass shooting incidents, and then the mass shooting deaths total number. So we first had to start with the augmented Dickey-Fuller test, which is a statistical test that helped us distinguish meaningful data from just mere noise. Achieving stationarity with our data was crucial because the ARIMA model actually requires a stable baseline to predict future values accurately. So while we were developing our ARIMA model, we appropriately selected the order of the model's complexity, and it matched it with the little subtleties of our data. And then the ARIMA model basically became like a key instrument in revealing past data points and their influence on future outcomes. So our results were actually telling. The augmented Dickey-Fuller test showed us that our data actually did not just wander aimlessly, and that there were actually detectable patterns. And then this result was very pivotal because it gave us the confidence and the reliability in our predictive models. So diving into the ARIMA model's outputs, we found out that the moving average component was particularly telling for mass shooting incidents, which indicated a significant impact of past errors on current values. But then the autoregressive component, however, it was less predictive, which challenged our assumptions on the influence of past values on future trends. So visualizations explained. If we take a look at these two visualizations, the time series plots are a historical record with the trend lines drawn from our regression analysis, which paints a clear picture of the direction and magnitudes of the trends that we're observing. As you can see over time, the total number of US numbers actually goes down, but there is a slight increase in the number of mass shooting incidents, and over here the number of mass shooting deaths. So something very insightful that we found out. And then we made these diagnostic plots, which were a critical component in our analysis. The correlograms, for instance, should ideally show no significant autocorrelation, which would indicate that our model has accounted for the data's internal dynamics. However, we observed some patterns and departures from randomness, which suggests potential avenues to make our model a little better and refine it a little bit. So in conclusion, our analysis has been revealing journey into the dynamics of these tragic events. Through our ARIMA models, we've gained a clear understanding of the patterns and trends hidden within the data, and these results have highlighted both the potential and limitations of our approach. It suggested avenues for further research and refinements. Our visualizations have not only supported our statistical findings, but also brought to light the complexity and nuances of these serious issues. And as we continue to do this type of important work, our goal remains to deepen our understanding and enhance our predictive capabilities, uh, eventually contributing to informed strategies that could help us mitigate these sort of incidents in the future.
In conclusion, our in-depth analysis of mass shooting data in the United States has unearthed a variety of insights and complexities. We meticulously examine the correlations between socioeconomic factors and firearm legality and the frequency and the severity of mass shootings. Our findings reveal significant correlations in certain areas, notably between the legality of firearms and the number of victims. And however, other anticipated correlations like educational attainment and mass shooting occurrences did not show any statistical significance. This study also explored the temporal patterns of these incidents, revealing no discernible difference in their frequency on weekdays compared to weekends. Uh, as I said, this counters common perceptions and highlights the unpredictable nature of these mass shootings. Our time series analysis further accentuates the challenges in predicting mass shootings, underscoring the need for sophisticated analytical approaches. Through these statistical methods and machine learning models, we also attempted to forecast future trends. While these did provide some insights, they also underscored the limitations and complexities in predicting such sporadic events and such multifaceted events. This illuminates the intricate interplay of various factors in a mass shooting, and this also emphasizes that we need a holistic approach in addressing such critical issues. So at through this, we advocate for data-driven policy making, emphasizing that strategies must also encompass social, economical, and legislative and psychological dimensions. Um, it calls for continued research to inform policy interventions and societal efforts to mitigate and eventually prevent these tragic incidents. Thank you.